there. So when we think of AI, we also think now water is life. That's something that we all understand on a personal level. Everyone drinks water, and water is life. And data centers need water. And so more than ever, there's the water energy nexus, and the interconnection is extremely strong and for infrastructure growth and data center expansion. So we want to know now how to optimize our resources. So I want to invite to the panel Rotem Ad, Chief Business Officer H2 Pro, Hila Gilboa, VP of Finance NT Tau, Eden Bozin, Investment Principal Ormat New Ventures, Gal Saf, Head of Innovation Communities Division, Ministry of Economy and Industry, moderated by Ravid Levy, Managing Director, WaterEdge IL.
Yeah. Are we on? Are we live? Okay. Of course, we'll wait for just a few minutes for the people to move around and take their seat. Okay. Wonderful. So welcome to the first water session in an energy conference ever, maybe, in Israel. Maybe not, but I'm extremely happy, really, personally, that this is a main event on the main stage here in the Energy Week, and thanks to Sean and Eshel and all the Ignite partners, our partners here who invited me and us to talk about this unique topic, and we will try in the next 30 minutes to convince you that this is the place to discuss water. And why? Because there's hardly anything in energy that is not connected, depending, or feeding the water sector. And we will try to cover a few examples here, very far from exhausting this very, very wide topic. Just to give few fun facts, or just few perspectives of this to put things in context and to jumpstart the discussion. So just for the perspective, Israel uses almost 10% of its power production for the water sector to provide water to all different users around the country. This is almost the highest in the world. The world average is 3 to 4% that goes to water. In Israel, we are something between 8 and 10%. That obviously goes to desalination, but also to moving water from one point to the other. Just appreciate the fact that the Kinneret is the lowest freshwater lake in the world, minus 200, and we're taking that water practically to Jerusalem, which is plus 800, and that's a lot of water that takes a lot of energy just to move it from one place to the other. Obviously desalination, but also reuse, treating all the wastewater, delivering it to irrigation. We're very proud of that, but that takes a lot of energy as well. The equivalent of about 1 million people, 10% of the population, 10% of the energy. So that's quite a lot. From a very different side of the energy world, for every barrel of oil that is produced globally out of the ground, there is 3 to 4 barrels of water that is also produced as byproduct that needs to be dealt with somehow. So in fact, you can call the oil industry water industry with $100 a barrel byproduct. But they produce much more water than oil and needs to do something with that. By the way, in some oil fields, it's 10 to 1, 10 water to 1 oil. And just finally, a final fact, there was a lot of talk here about data centers and AI. So everybody talks about how much water, especially in the US, how much water is needed for cooling data centers, right? But the fact is that data centers use 3 to 4 times more water indirectly for power production and for microchip fabs than for direct cooling the data center itself. So the scope 2 or 3 of water used by data centers is actually much higher than what takes most of the focus. So these are just random examples. So today we'll try to look with few experts and few innovators here from the energy sector mainly and from the Israeli government about the different sides of how these two things connect. And I will just leave the distinguished speakers here to present themselves. So just take a quick round of introduction, who you are, what's the organization or company that you come from, and how your activity connects to that nexus. How does the water energy nexus really connects to your activity?
Hi, my name is Eden, and I'm a principal at Ormat New Ventures. It's a venture capital arm of Ormat Technologies. Ormat is a large geothermal and renewable energy developer. We develop and operate in projects around the world. So our role as a CVC is to look at early stage energy technologies, mostly hardware, that could be eventually implemented in our future projects. So it could be anything related to geothermal, energy storage, or other renewable energy infrastructure where we build and run assets. Although we do not invest directly in water technologies, but water does show up almost in everything we do. So for us, the water energy nexus is about how technologies could operate in real world conditions where water availability and quality and handling issues could either enable or limit deployment at scale.
Thank you.
Hi. Hi, I'm Ila Gilboa. I'm the VP Finance for Antitau. We are developing a compact fusion power energy system. We are a deep tech startup. The aim of what we do is to create safe, clean, 24/7 decentralized energy source that is not dependent on grid, geography, weather, and so on. And this can be used with, for data centers, for maritime, for critical infrastructure, for everyone that needs energy. It can be behind the meter as well. And because, as you said, water is such a critical infrastructure and needs a lot of energy, we signed an MOU with Mekorot, the National Water Company of Israel, to start talking about a strategic partnership around it and to create our solution for this critical infrastructure of water.
Thank you. That's I must say, a surprising match between the utility and the startup. That's very interesting.
Hello, a pleasure to be here. Rotem Arad, CBO H2Pro. At H2Pro is a scale-up. We used to be a startup. We are growing and putting together our first commercial systems now. What we are trying to do is green hydrogen, and it's directly related to water, if you think about it for a second. So gray hydrogen is made out of fossil fuel. Green hydrogen is made out from water. So we are taking water, we split them into H2 and O, so hydrogen and oxygen. And what we are trying to do is actually trying to achieve fossil parity with green hydrogen.
Great. Thank you.
Hi, my name is Gal. I'm in charge of the growth and the innovation division at the Ministry of Economy of Israel. Basically, our job is to do SWOT analysis through the innovation communities and through events like this. And again, thank you to all the team here and to you, Ovid. From the company level to the segment level and to the whole market, and to try to produce, to match it with growth tools that match these opportunities and barriers. Other than the tools that I will talk about it later, we also see the Nexus as a part of the a very structural and very natural combination. This is why also from the next coming years, as you know, our national innovation communities in water and energy will run operated together and side by side, because we see it as a close match, and the tools I will touch a bit later. Thank you.
Thank you. Great. Now in the next round, we'll try to dive a little bit deeper into each one of the different technologies and see how that nexus connects and actually works in that. We'll start with hydrogen. With you, Rotem. So as you said, there's no green hydrogen without water. That's the raw material, plus power, of course. However, many of now or soon when, as you said, green hydrogen projects will scale up, that will happen in many places that are very arid or very limited with water, but they may have a lot of potential for green power. So how does these two will work together, and how do you see water being a limiting factor or an enabler for green hydrogen?
So yes, first of all, we need water. Interesting enough, because we get this question quite a lot, water is a limiting factor because you cannot produce without water, you cannot produce green hydrogen. At the same time, it's not the major limiting factor. And let's talk about numbers for a second. So for 1 kilogram of green hydrogen, you need roughly 9 liters of water. Sounds a lot, but if you think about it, desalination, which we all drink every day, and you do the math, this is coming up to maybe less than half cent, maybe 0.3 cent for 1 kilogram of hydrogen. It's basically nothing when today fossil hydrogen, it's around €3 per kilogram, $3. Maybe a little bit less in the US, because the fossil one is based on gas, and this is the key element there. So desalination is possible, and let's take an example, because let's discuss it with number. If we take a mega project, 1 gigawatt of electrolysis, like half of the size of NEOM, which is in Saudi Arabia, which is the largest project that happening today in the world. 1 gigawatt of electrolysis, so you need 1 gigawatt of electricity, and you need water. So you need a line of 180 cubic hour line, which is a Coca-Cola factory, which is a small neighborhood or maybe a very small city. For a gigawatt of electricity on the other side of the equation, you probably, I did not me, but my AI from the previous session made some calculation, and probably you need the all amount of solar energy of Israel for this 1 gigawatt factory. At the same time, you need 1% of Sorek desalination plant. Mm-hmm. So water is an issue. You need water for electrolysis, but you need electricity. And this is actually what we are trying to focus on at H2Pro. We are trying to connect our electrolyzer to the cheapest electricity, which is renewable. So current electrolyzer in the market, they cannot work intermittent. They need a base load 24/7. So if they connected to cheap electricity, they need batteries, they need the walk around, and we are designing and actually deploying now system that works directly on renewable. And by doing that, we can achieve very cheap hydrogen, which is the solution for fossil parity. Again, I'm coming back to numbers. So if you connect electrolyzer to the grid in Europe, €100 easily per megawatt hour, this is equivalent to €5 per kilogram of hydrogen, just the electricity. If you connect it to off-grid PV at €20 per kilowatt hour, you are at €1 electricity, and then you can compete with fossil parity. Mm-hmm. So water are important, electricity more.
That's reassuring, really, because so basically it seems like when there's lack of a packaged desal system can be part of the overall development and mission accomplished. That's great. So we're kind of tick the box around water for energy production. Now let's look at power for water production. So Hila, this again, as I said, this collaboration is for me mind-blowing. You know, taking a water utility, matching it with a fusion, you know, futuristic maybe, at least for me. So how does this collaboration with Mekorot work or will work? How do you see this synergy between those kind of two organizations, and what are the actual plans going forward on that?
Okay, so I think that for Mekorot, they are looking for additional energy, and they are very innovative. I learned that, and so this is really giving them early exposure to the fusion technology. For us, actually, when we go to different conferences, sometimes we are asked, okay.
Yeah, it's not.
Can you hear me now?
Yeah.
Okay, so I'll repeat what I said. For Mekorot, they do need additional energy sources, and they are a very innovative company. So we are giving them in this MOU, we are giving them early exposure to the fusion technology. For us, when we go to different conferences, it's funny. Sometimes we are asked, okay, can we order the first machine? So no, we don't have it yet. What we do need now is partners, strategic partners that will help us define the use cases and the requirements and all of that. And Mekorot is really a visionary strategic partner that can help us do that. So this MOU is really a great combination of what they need and what we need. The steps for it is something that is still in discussion, so I can't go into the details, but it's definitely worth for both sides.
Thank you. So for sure, water resources and water supply is a critical infrastructure that we cannot allow being shut down, and we saw some examples in the Gulf lately of desalination and other infrastructure being damaged. So I think that could be also part of this self-sufficient power supply for critical water infrastructure. By the way, hydrogen, I think, is also a possibility there. Great, thank you. So Eden, now to you. As a CVC venture capitalist within a corporate, it's with a corporate, as you said, that is in a way relying or connecting with water for the power production, geothermal. When you look at innovative technologies for your portfolio, how do you see this water energy nexus, and in what ways it shows up maybe in ways that we don't expect or we don't really think of?
So from our perspective, I would say water is normally not the headline of the energy conversations, but it could be one of the limiting factors if you want to scale, especially in very dry regions or infrastructure constrained geographies, and for periods of 20, 30 years, which is what you usually sign with the local utilities through PPAs. So I want to give two examples that normally people would not think of, and they are closely related to what we do at our CVC. So first is related, of course, to geothermal power. The traditional hydrothermal, geothermal is a great source of baseload power, but it's geographically limited. It's still a niche because you have to find rare and naturally occurring hot underground water reservoirs. So the novel geothermal technologies, what they aim to do is to create this kind of reservoirs artificially. For example, EGS, enhanced geothermal systems, which got a lot of attention recently due to Ferroenergy IPO. What they do is they drill through hot, dry rock, they inject fluid, they crack the rock, and then circulate water to bring the heat up. So in this kind of projects, the water constraint is a big part of the physics and the economics. First, you need a lot of water to create the reservoir, and during the stimulation phase, and then you need to consider the loss of the fluid to the rock formation and a lot of uncertainty that is happening on the ground with these novel technologies. So to put it into perspective, if a developer wants to build, let's say, 100 megawatt plant that could supply power for like mid-sized US city of 75,000 households, just at the stage of creating the reservoir and the stimulation, there is a need for tens of millions of gallons of water, which is like well over 100 Olympic pools. And it doesn't end there because there is a flat line on the projection. There is a flat line of water loss throughout the whole life of the project. And even under very optimistic scenarios that the company have, you're still going to lose up to 4% of the water, and during the first months it could get a lot higher. So you need to always compensate on this water loss and consider that this geographical formation usually happen in very dry regions, like for example in the US, Utah or Nevada, regions with water scarcity. Then you have to source this water, you have to bring it there and keep it coming for many years. So of course it can kill the economics. And another example that I would like to give is also from our portfolio, even less intuitive, from a battery recycling industry. In the battery recycling sector, the water consumption aspect is usually overlooked, but the traditional battery recycling uses huge amounts of water. First, it's the shredding, crushing the batteries, and then you receive something that is called black mass. It's very water-intensive process. And following that, there is a hydrometallurgical process that uses a lot of water and chemicals in order to extract the valuable materials. So let's say if we want to put this one into perspective, you want to recycle like 10 battery packs from Tesla car, just the hydrometallurgical phase you would need around, depending on the technology, up to 100,000 liters. This is something that...
For just how many batteries?
10 packs. And then this is something that a household in a Western world uses for over several months. And that's only the hydrometallurgical phase. And then what you receive from these 10 packs is enough to create 4 to 6 new battery packs, okay? So our portfolio company Novocycle, their method is aimed to replace both the shredding phase and potentially the hydrometallurgical process altogether. Using their process, they disassemble the batteries with dry thermal treatment. It separates the electrolytes and the binders without using any water. And on top of that, out of the materials that they receive in the end of the process, from those 10 battery packs, you could create more than 9.5 new battery packs. Yeah. So these are my examples.
I must say this is very interesting. In terms of the concept, it sounds a little bit like what they're trying to do. I couldn't avoid the term data centers with low water or no water cooling, bypassing the water limitation by new innovation. So that's a very interesting direction. I want to broaden the perspective a little bit beyond the specific technology. Gal, to you. We know that Israel is great at venture creation and in new early stage innovation, but when it comes to power or energy and water and in general deep tech, scaling up is a huge challenge. I mean, it's very good to get maybe to the pilot stage, but then some of the challenges still lies. So where do you see, as the government or the Ministry of Economy, the main hurdles on that path for Israeli startups or companies, and how and in what ways can, again, the government or the public sector help?
Great, thank you. I see I don't have a lot of time, so I'll try to be short, so we'll have time for this. I would say that's a good question, because the difference is if you have a cyber or software startup, you need not a lot more than a laptop and cloud space, or maybe with AI infrastructure a bit more, but obviously that's not the case for this kind of infrastructure technologies. Nexus or not, infrastructure as a scope. And we identified two main points that we can help. We're already trying to help this year, and we will help next year, and I hope that there are people in the audience that could be relevant to them. Two main things. First, we're talking about a scale-up. It's right, the R&D phase, it's a lot more in what Dror Bin has said this morning and in their side of the equation. And we go not to 0 to 1 stage, we go to 1 to 10 stage. The scale-up, the physical activity, to take lab-tested technologies and to take it to the next level. First thing that we do in this case, we have the cluster infrastructure grants. Last year, I would say, in the energy sector, we had the Shikun and Binui together with the Ramat Negev R&D Center to doing a 25 million shekel project on agrovoltaic. We gave a grant of about 6 million for that purpose, to mitigate the risk, to try to get, to do the first push. This is what we can do from our side. And we have a lot more examples like this. The other side is we're trying to take the information, the digital infrastructure call we had this year, and we have a 15 million shekel, hopefully for next year, election and all, but hopefully everything will be okay, to get, and I hope there are people from ICI here, or the electric company ECI, or the water corporations that has to know this. We are trying to push these infrastructure giants to open up the information, open up the data, to create an ecosystem of technologies to be first tested in Israel first, that we can take this data to learn it, to not us, I mean the free market, the open market, the sector, to learn these challenges, to learn the options, to learn the opportunities from that. As I said, everything comes back to the SWOT analysis that we do and try to take it to the next level by creating tested in Israel first and then going outside. The next level is to take it through the what we call ready to export. A lot of tools that I will not say in the short time I have, but with our economic attaché platform, 45 offices around the world that can push these tools, and we have a lot of grants and subsidies that we give to technology companies, not only startups, by the way, technology companies that have Israeli technology to export, to go out, to do pilots, to do demos, to do even just promotional efforts around the world. And through the active, I would say, efforts or guidance of the communities of WaterEdge, of Ignited Spark, EnergyCom, and others, to try to get everything back to the same place and to touch that we will know what are the main issues that the startups and technologies are dealing today, and what are the main issues that the infrastructure companies are handling today or facing today, that we can try to, at least from our side, doing kind of again, scale up and mitigate a bit the risk to create solutions.
So from startup nation to scale up nation, I mean, it's maybe it's time we will start to also think and build towards that as nationally. So that actually brings me directly for the last few minutes to the final round. We'll consolidate all that into maybe one question. So where, that's for everybody, where do you see the main valleys of death, plural, because there's no one, I guess, going from idea or research all the way to scale up in these sectors, in the intersection of water and energy, and to the investors here, and then mostly you, and maybe also Gal, what is the function, or what can investors do in order to accelerate and to do that better with innovators, and to the startups in here, what do public or large corporations and mainly government still misunderstand about what startups needs in order to go there?
So I'm holding the mic. I will try to do it quickly. The road for bankability is starting from a startup. We have quite a lot of them here, moving for a pilot, the scale-up phase pilot, moving from lab to pilot to a demo to first of a kind, and to commercialization, i.e. bankability. In infrastructure, in energy, I mean, out of the AI software thing, it's a lot of money, a lot of time. So it's time and money. And unfortunately, I think the Israeli government is not doing enough. Raising money right now for an Israeli company, for infrastructure, first of a kind, require a lot of money, and it's easy, it's not. Yes, there are some mechanism with the Israeli government, but it's really, really little in comparison with what you can get outside of Israel, and it's needed because it's a long journey.
Okay, so from my side, first of all, I agree with what you said, with a lot of what you said, and for us, for Fusion, it's really getting the product from the lab to the real world and then to mass production, which is not easy. For us, we need to create a technology, but we do need the partnerships, as I said, like Mekorot, the strategic partners to understand the use cases and the requirements to get it to the real world. And then we would need strategic vendors to get this into mass production. Also, because our product is compact and modular and decentralized, this will help us to get this really globally. I did agree with what you said, both on the investors and on the government. So I think that for investors, they need to understand that energy and water are different from software, and it's not the same timeline, and it's not the same amount of capital, but then the result can be huge. Like the valuation of fusion companies is billions. So they need to understand that, and they need to understand that it's not just looking at the few $1 million of first revenue, but on the tech understanding, the regulations, the IP, all of that. And I think that for the government, we are all attacking you here. It's important to understand that for fusion, you need an ecosystem. So it's not just giving grants to one company. It's building the ecosystem, the talent, the lab infrastructure, national lab maybe, things like that, that would help. And other governments are doing it and really contributing billions of dollars for that, because energy is critical infrastructure.
Thank you.
So the time is up. I'm not sure how. I'll try to be very brief. So we are an energy sector investors. So how we look at water sector, water tech technologies is an enabler, because behind, as you said in the beginning, behind almost every next generation energy project, there are several water bottlenecks that are in desperate need of innovative solutions. And I think that Israeli water tech expertise could be highly relevant here. And I definitely think that is something that could be added to their pitch. We are enablers for global energy transition at scale. Many bottlenecks could be relevant here, like purity with the hydrogen sector, but I think the biggest one is the volume. It's relevant to all the industries, traditional power plants, nuclear SMR projects, of course, the cooling of the data center, and we cannot keep using fresh drinking water to answer those needs. It's just not sustainable. There have to be solutions that bypass this and utilize the wastewater from industry or from agriculture. Like, for example, in EGS project that I've mentioned before, one of the questions that dictates whether the project will even happen or not at all is where do you source this water and how do you keep it coming for years? So the technologies that would allow the developer to use, let's say, municipality wastewater could be highly relevant.
Reuse.
Yeah, and in geothermal there is also a chemistry bottleneck. We deal with a lot of highly aggressive brines that contain chemicals that could totally destroy the equipment or clog it with some minerals. And any technology that knows how to deal with kind of chemistry is super relevant. While on it, there is a lot of lithium in this brine, and advanced solutions to extract this lithium could also assist the battery supply and chain. Well, regarding the scale, I think my colleagues here have already mentioned a few things, and we're very harsh with the time, so that's it.
Yes, you're right. Thank you. I got just one final word. Yeah.
Sorry, seconds, because I was last in the microphone. I just want to say that I hope that anyone it's relevant to will exit the room, or I mean, everyone has phones. Google growth tools or Klet Tmicha in Hebrew, and try to find the things away. Two short things that are relevant to the first of a kind solution that we said. First is the regional growth directorates that we are building in the municipalities. We have a tool. Already have 7 regional innovation that run by municipalities from the north to the south, and we have a plan to do another 6 next year, hopefully, that will try to focus specifically on specific niche, on specific sector. It can be blue economy, it can be this nexus, or it can be only energy, only water. That has our backs and our backing and our, not a lot, but some money, to try to focus on first of a kind on its municipality and to try to bring investors and technologies to this. The second thing is to take again, I'm representing Ministry of Economy, sorry, not the whole government of Israel. And the Ministry of Economy had a focus on countries in this relevant nexus on India, Germany, and the UAE. Specifically in India, talking about the IMEC, the corridor, the green energy corridor through Egypt to the UAE and then to Europe. We are hoping a lot and counting a lot on this to happen from India in time and desalination in terms of green energy that will hopefully get a lot of first of a kinds in Israel and from Israel and act as India through Israeli technology and add an Israeli product and green energy to the rest of the world. And I hope it will work.
One word.
Just one.
Inshallah.
Inshallah, exactly. So yeah, I agree. The IMEC could be an amazing opportunity for these two things because it just happens to go through places where water and energy are a major issue, either having a lot or not at all. So we'll have to deal with both. That's it. We're wrapping up. So thank you all for your attention and thank you for your time and insights and drink some water. It's good for you.
Thank you to the whole panel.